Hi everyone, let's discuss question 23 in topic set 8 in Chem 11. This is a question about Lewis structures again and using it actually to determine two different compounds that have exactly the same formula. And we're going to also incorporate the idea of molecular polarity to help us distinguish between these two structures. So the question is just asked us to draw the compound XeF2Cl2 as we've been doing with the other Lewis structures drawing. Let's just start with the valence electron. So 8, 2 times 7, 2 times 7. So that ends up being 36 electron. Our xenon is in the middle. And the way we can draw this is two different ways. One is this, where we put the chlorine next to each other, bonded to the xenon. Or, as you can see, now let's just kind of look at this drawing before we continue. Right now, I've used up 1, 2, 3, 4 per terminal atom. I have 4 terminal atoms, so there's 16, which is 32 electrons. I have 36 here. So let's finish by adding 4 more electrons to the xenon, and that would give me the correct structure for xenon difluoride dichloride, right? But let's now take a look at a different way to draw this molecule. If you draw it this way, that's actually slightly different than the one that we just drew. So again, putting all the lone pairs in the terminal atom, we now have this structure. Now the question is, what's the difference between the two structures? The difference can be discovered by looking at the structure of the molecule. So if you look at the electron geometry of that central atom, this is a octahedral electron geometry. The molecular structure though is square planar, right? So both of them have that same electron geometry and molecular geometry or molecular structure. They both have octahedral and square planar. Now square planar of course means this. If you draw it out, this is what square planar looks like. You have your central atom right here, and depending on what you put across the xenon, there's two different types of molecular polarity that you get. So if you put FFCl, what's going to happen is, because the dipole vector or the bond dipoles goes away from the xenon, since the red ones here are going towards the same atoms, in this case fluorine, they're going to cancel out. And if I draw a different color for chlorine, and they have the same atoms on both sides, and they're going to cancel out as well, which means the overall dipole moment is going to be 0. So this is going to be a nonpolar molecule if you draw it this way. And of course, that's what this second structure that we drew earlier was. Now let's take a look at the other structure. With the other structure, also square planar, Xc in the middle, except that now, in this case, our bond is to F on one side, Cl on the other side, and F on one side and Cl on the other side. If you do it that way, then using the same color coding, you got these two reds as the bond dipoles, and then for the chlorine, you have the two yellow ones. But what happens is they don't cancel out, because the sum of these two is not going to be 0 because they're not the same type of bond vectors. The length is different because the difference in electronegativity between xenon to fluorine and xenon to chlorine are not identical. And as a result, if you add the bond vectors together, you're going to get a dipole moment that is not equal to 0, which means you're going to get a polar molecule. And so that's how we're going to be able to tell which molecule is which, because one molecule, which is the one here, is going to be nonpolar, and the second molecule, which is the one here, that's going to be polar. Okay?